Hello everyone, welcome to our lesson 10 where we shall deal with the problems and how to answer them. This is student problem solving session. When you see SPSS, it is about showing learners how to go about questions. So the previous lesson I'd asked you to show how you can put a string around given number of pulleys. I'd ask you to do it and determine velocity ratio when you have 4 pieces and 5 pieces. Now, at the same time, I warned you that velocity ratio is not necessarily the number of pulleys. So I want to give you an example here. I have 1, 2, 3, 4 pulleys, okay? And I've put the rope around them so that you may understand what I mean, okay? What do I mean? Now, if you put this rope around the way I have shown, it will be hooked between the lower pulley and the upper pulleys. Okay? So, remember how I told you the surest way to determine the number of pulleys is to see the tension in the threads. Tension in the threads that hold the load. So this load is being held by this pulley, and this pulley will therefore have tension here, there, and there. So we say velocity ratio is equal to 3. You can see I have 4 pulleys, but velocity ratio is 3. So the number of pulleys is not automatically the velocity ratio. In fact, this is called convenient pulley. Convenient pulley. Okay? This is a convenient pulley. It is just for conveniency. Otherwise, even without it, if I don't use this blue pulley, the thread should be coming here. The thread should be coming here. There. Okay? I can put the thread, I can pull it from this point. But I've decided to be more, maybe fashionable, or depending on the distance where you are and where your work is to be done, I can add another pulley, fixed pulley up there, which will be known as convenient pulley. So that part I've finished. Come to what I gave you to try, assignment. I have a set of 5 pulleys here. Let me focus a bit now, this side. I have a set of 5 pulleys. 1, 2, 3, 4, 5. So I want to show you how to put a string round and also how to determine velocity ratio. I will use the red pen. So let us start the way I suggested. This is the effort. Then it has to come down, go around the lower pulley, then go to second, keep on moving until there. Once you've reached there, then it is hooked by the lower pulley. So I want to hook it. I put my hook there, come that way. That is my hook. Then this is the load. Okay? Then these ones, you also connect them up to there. They are connected. Okay? That is what I expected you to do. Okay? This is the hook there. Now, if you are asked, show on the diagram how the rope is wound and the effort applied. That is the answer. I've shown the effort where it should be applied. I've shown how your rope will go around the 5 pulleys. So let us imagine it is 2 marks. One will be for showing effort, and then the other one for showing the way it will go round. Okay, so from there, let us learn how do you get the velocity ratio. For example, how would you get velocity ratio? So let me again just do something small here so that I have enough space for this hooking there. So if you look at this load is being pulled by this pulley and that pulley. So the tension, if I want you to get it well, the tension I talk about is here. If you look at it from this level now, there. If you look at it from that level, you will find there is a tension here, another tension there, another tension. Those are 5 places where you hold the string so that the load remains in position. Those are the 5 places where you hold the string so that the load remains in that position, and that will give you the velocity ratio. Okay, so I have revised that. Now I want just to continue. Suppose I'm giving a question regarding this and not that. This one, remember, was to show you velocity ratio is 3 as opposed to velocity ratio is not equal to 4. Velocity ratio is not necessarily the number of pulleys. Now I want to continue with this. Number 2. Okay, so we are doing number 2. This was number 1. This is 2. Whenever you are given a question, you must remember to sort out. So this diagram here has velocity ratio. This diagram has velocity ratio equal to 5, and the efficiency is 80%. The mass, the load here has a mass of 200 grams. 200 grams. Now, calculate mechanical advantage. Calculate mechanical advantage. So if I want to calculate mechanical advantage, is equal to load over effort. That is the formula. Mechanical advantage is load over effort. Any question you are asked to calculate is a formula-based question. Therefore, the first thing you do is sort out what has been given. What information do you have? This is what I mean sorting out. A letter and the quantity given. You must take care of units. So this is the information I have. You may omit this depending on the way you approach things, but to me it's very important because it is this which pricks your mind to think of the right formula. Number 2, you write the knowledge. Remember what I said? Sort out, write the knowledge, then substitute and compute using the correct units. And then you get the final answer also with the correct units. So we know mechanical advantage is load over effort. Okay, we are asked to calculate mechanical advantage. Then the next formula which you have is mechanical advantage. Efficiency is mechanical advantage over velocity ratio. So I have 2 pieces of formulae that contain mechanical advantage. Now, the information you had will tell you which one can you get. In both cases, you have a 3 quantity formula. 1, 2, 3. Even here, 1, 2, 3. Okay. A 3 quantity formula requires 2 quantities for you to get the third. If you have 4 quantity formula, you need 3 so that you get the fourth. In view of these two, I will pick this because I have here 80 over 100. That is the efficiency. Mechanical advantage over velocity ratio 5. So mechanical advantage, you compute that, it comes to 4. That is 5 times 80 over 100. Okay? 5 goes into 100 20 times. 20 goes into 80 4 times. So that gives me mechanical advantage. The help has come from what I sorted, which essentially means those are the pieces you will use to construct your answer. To construct your answer, you must have the correct formula. Okay? So that is how you'd get the mechanical advantage. Now let us look at the effort. I don't want to remove this so that you can refer to it. I will try to use the spaces available. So suppose I have this as part 1. This is part 2. I'm asked about effort. So what is the effort applied? And I have to get the formula where effort is. Mechanical advantage is equal to load over effort. Okay? When you substitute this, you get 4 is equal to load. Load must be in newtons. Okay? In newtons. So, remember, effort is in newton, is a force. Load is also a force. So 200 grams. How do you convert 200 grams to newtons? It is as simple as dividing by 100. So I have 2 over E, and then what do I get? I get mechanical advantage is 4, so I have 4. Load over effort, then I'm asked about effort, so effort is equal to 2 over 4, which is 0.5. This is Newton. Okay? 0.5 Newton. That is how you'd go about it. You have to get mechanical advantage. Load and effort, we can have them in Newton. Okay? The load I was given 200 grams divided by 100. That is direct conversion. Otherwise, change it to you can change it to kilograms, 0.2. Okay? That is by division by 1,000, and then multiply by 10. Okay, you get 2. You will still get 2. 0.2 times 10 is 2. So directly you put here 2, load is 2, and then I don't know the effort because I'm being asked. Then it becomes 2 over 4. 2 over 4 is a half, which is 0.5 newtons. Folks, that is the way you will handle things. I've tried to capture the efficiency, mechanical advantage, effort, depending on the scenario. Try to do question that will test your ability to interpret work output over work input times 100 to give you efficiency. Bye bye, folks. We meet in lesson 11.